So thus far, the absolute motion of a particle has been determined using a single fixed reference frame. There are many cases, however, where the path of motion for a particle is complicated, so that it may be easier to analyze the motion in parts by using two or more frames of reference. For example, the motion of a particle located at the tip of an airplane propeller while the plane is in flight is more easily described if one first observes the motion of the airplane from a fixed reference, which could be possibly the ground, and then superimposes the circular motion of the particle measured from a reference attached to the airplane. So let's discuss relative position. Consider particles A and B, which are shown below, okay? They move along the path shown. Particle A follows this path, particle B follows this path. The absolute position of each particle, r sub A and r sub B, is measured from the common origin O of the fixed XYZ reference frame. We have this fixed reference frame of fixed observer. Okay, we have point O here, and then we have a position vector r sub A, which goes from O to A, and another position vector r sub B that goes from O to B. And then over here, we have another reference frame. This will be the translating reference frame, the X prime, Y prime, Z prime reference frame. So the origin of this second frame of reference, X prime, Y prime, Z prime, is attached to and moves with particle A. The axes of this frame are permitted to translate relative to the fixed frame. The position of particle B measured relative to A is denoted by the relative position vector r sub BA, which is directed from A to B. So using vector addition, the three vectors shown can be related as follows. We have vector r sub B equals vector r sub A plus vector r sub BA. And remember, these are all position vectors. Okay, these two here that only have a single subscript, again, are the absolute position vectors measured from point O of the fixed reference frame. Whereas this term here, the position vector with two subscripts with a slash in between them, that represents the relative position vector. Okay, that would be directed from A to B. So notice the notation here. The subscript is B slash A. So that always means, in that order, always means that the position vector is directed from A to B. The way that you read this would be the position vector R of B with respect to A, or the position vector R, B relative to A. And that implies that A is the starting point. So it's important to get that notation correct, that subscript correct. So using head-to-tail method of vector addition, we see that vector r sub A plus vector r sub BA equals the vector r sub B, and that's what we're saying here. We can determine the relationship of the velocities of the particles by taking the time derivative of the previous equation. Therefore, we have the following. We have velocity vector v sub B equals velocity vector v sub A plus the relative velocity vector v sub BA. Okay, although here we're not showing any velocity vectors, the same general idea applies. Okay, so v sub B equals v sub A plus v sub BA. These two here represent absolute velocities, meaning what the velocity would appear to be from a person at point O of the fixed reference frame. V sub BA is the relative velocity vector of B with respect to A, and that represents what the velocity of particle B would appear to be from particle A, okay, the translating observer here. We can take an additional time derivative to determine the relationship of the accelerations of the particles to get this expression. Acceleration vector A sub B equals the acceleration vector A sub A plus the acceleration vector A sub BA. This is the relative acceleration vector of B with respect to A, or B relative to A. So once again, we have these two terms with a single subscript that represent absolute accelerations in this case, as measured from an observer at point O of the fixed reference frame. Whereas this term here, this acceleration vector, A sub BA, would be what the acceleration appears to be of particle B looking from the perspective of point A, or a person located at point A, which is the origin of the translating reference frame.